So before we start talking about indicators, which is the point of what we're doing today, I just want to do a real quick review of yesterday and start identifying titration types. I want to know what type it is. I want to know what's in the beaker, what's in the burette. So starting off here, I don't even want to talk about acid-base yet. I want you to first look at what is the most important part of this curve. The equivalence point. Shape doesn't mean anything until you locate that equivalence point. So what is the equivalence point telling you? Okay, I just heard mumbling. Right, but what is this particular equivalence point telling you? It's higher than 7, so what does that mean? Strong base, weak acid. In addition, I want to know what is in the beaker and what is in the burette. What's happening to the pH as the titration is going on? It's increasing. So what must we be adding? Base. So the base is in the burette, and then the acid is in the beaker or the Erlenmeyer that we're using. Okay, so that's the first type. It's a strong, weak titration. Let's take a look at this one. This one's pretty easy to identify because if you notice, the first thing, where is this? pH equals 7. You can see how extreme that sharp rise is. So because it's a pH 7, what do we know? Okay. In addition to that, we need to figure out what's in the burette. So what do you think is in the burette? The base, because the pH is going up. We're starting at a low pH because the acid is in the beaker. Okay, and the last one we'll look at is this one. Where's the equivalence point? It's 5. And a lot of people were saying last period that this is strong, strong. It's not strong, strong. We have a steep rise, but it's not very long, and there's definitely stuff going on at the beginning that's weird. So you have to look at that equivalence point. Our pH is about 5 here. So it's a weak base, strong acid. So always look at that equivalence point first. Weak base, strong acid. What's in the beaker? The base is in the beaker, and the acid is in the burette because the pH is dropping. All right? So that's, in a nutshell, what the types of titration curves are. Now what we're going to talk about today are something called indicators. You've used an indicator before a couple of times in Chem 1. We did a titration this year as well where we saw indicators changing colors. What indicators themselves are, they themselves are weak acids or bases. So what's going on when they're in an actual equilibrium situation? H is the H hanging on to an indicator, and if we add water to it, we can shift and mess with the equilibrium and make this happen. Indicators will change color when that kind of thing goes on. And what you need to know specifically is because these things are weak acids and bases, phenolphthalein, bromothymol blue, all these different indicators, they have their own K values. So what you need to walk away today with is knowing that indicators will change color at their pKa plus or minus 1. So this is phenolphthalein. It has a K of 1 times 10 to the negative 9. So what's the exact point it's going to change color? What's the negative log of 1e negative 9? Do not pull out your calculator for that. 9. 9 is when exactly it changes color. I'll talk about the plus or minus 1 in a minute. But this is what we call the end point of the indicator. The end point is the point where the indicator changes color. So if we're doing a titration, we want to pick an indicator that has an end point close to what in the titration? Close to the equivalence point, because the equivalence point is what we're looking for. So rather than having to construct a curve like this to find the equivalence point to find the mils, we can use an indicator, knowing the indicator is going to change somewhere in here close to that volume. We can figure out the volume that way as well. So that's how indicators work. So again, indicators are weak acids and bases. They change color at their pKa plus or minus 1, and the point at which they change color is called the end point. The end point is not the same as the equivalence point. Equivalence point is in a titration when moles of acid equals moles of base. Okay? So you don't have to really know this. I just think it's interesting to know why that whole plus or minus 1 range exists, and it has to do with what we can see. Bromothymol blue changes from yellow to blue back and forth. Because its Ka is that, we know that its endpoint is actually exactly at 7. But we actually see color change before and after that point, because if 1/10 of the color changes, then we see it happen. So where they came up with the plus or minus 1 is just this whole 10th concept. If we have a 10th of the acid turn into conjugate base, we put it in Henderson-Hasselbalch. Originally, if the moles were equal, it was 7, but if a 10th changes, we get a pH of 6. And then if we switch it and have the 10th in equilibrium the other direction, where a 10th of it is going from the conjugate base to acid, we get a pH of 8. So that's where the whole 6 to 8 comes from, and the plus or minus 1 comes from. It has to do with the visual thing going on in our eyeballs. All right? So when do indicators change color? Plus or minus 1, what does that mean? No, not plus or minus 1. When do indicators change color? At their pKa plus or minus 1. Okay? At their pKa. So you have a range of different indicators, and so based on what type of titration you're doing, you might not know exactly the concentration of your acid or your base when you're about to start a titration, but you know if it's a weak acid or a strong acid, so you'll be able to kind of figure out, okay, do I need an indicator that changes color below 7? Do I need an indicator that changes color above 7? And you can kind of work from there. One thing that I hear a lot of teachers think, and they take things real literally, and they're like, oh, we're not supposed to use phenolphthalein on a strong titration. And they get all, ugh. And I'm like, everybody uses phenolphthalein on a strong titration. You guys did it in Chem 1. Why are we allowed to? Phenolphthalein has a Ka of 1 times 10 to the negative 9. So its pKa is 9. So we see changes from 8 to 10. Where does a strong titration change color? Not change color, Jesus. Where is the equivalence point of a strong titration? 7. So we really want something near 7. But if you look at this strong curve, this is the equivalence point for strong. Phenolphthalein doesn't change color from there to there. Why is that okay? Everybody does it. Why is it okay? It's got to be okay for a reason. What about the sharp rise? What are we looking for when we're trying to figure out moles of this acid? What do we need from this graph? That volume, right? So what's the difference between the volume at the equivalence point and this, the volume there? Barely any, because that rise is so sharp. That's why in this particular titration, you can use phenolphthalein. You can also use the methyl red for the exact same reason. Okay? So phenolphthalein and methyl red are acceptable for this one. What about this? This is what type of titration? Weak acid, strong base. Are either of those two acceptable? Are both of them okay? Indicators. Yeah, phenolphthalein looks good because right there, hey, within our visual color change, we see that that's where the equivalence point falls. So we're good with using phenolphthalein. Is methyl red okay this time? No. Huge difference. Look at the top of the methyl red, which is your best case scenario. That is a significant difference in volume right there. So there's no way we could use methyl red for this titration and get a good result. So as you saw, it looks like most people, everyone, has like 128 views last night of last night's extra video. You saw that's how they're going to present you. They're going to give you a bunch of Ks of these indicators, and then you need to find the pKa and then pick the indicator that works best, and you want it closest to the pH of the equivalence point. Okay? It's a very common thing they'll throw at you. Make sense? Okay, that's it. Let's get ready for your quiz.